Got a 16 core processor up there.
Oh.
What were we talking about?
The elementary logic class. Like I
Yeah.
have to take it, but he does class.
But you have to take it, but he doesn't have to take it?
Well, you have to take it? I didn't have to. take it.
Why?
Really?
Yes, it is. It's required.
Oh, it's a prerequisite to do what?
No.
That's why I'm surprised why I haven't taken it. Or just taking it.
That's not a prereq for any of the computer science classes.
No, I was told it was required.
Well, they made that up.
It says in the new works,
Hmm.
but not for his.
So why do you have to take it for which?
For computer science major.
Yeah, I was told you had it.
Oh, hold on.
And then also discrete.
No, statistics.
It's just
I already-
extra-
I already had it.
You don't need discrete math for computer science. The only required math class in any computer science concentration is stats.
Which I did.
I'm guessing whoever you talk to is looking off of. Oh, it's probably got the wrong catalog year in for you. Because we used to require like Calc 1 and discrete math and introduction to numbers. If you just go online and look at the computer science degree, you'll see what's required.
It's changed.
No, it hasn't really changed in the last 2 years.
Or what I should say is like stuff that used to require is required.
Well, in the last 2 years, that have not really happened.
Or for me, even with like stuff that you don't think counts does academically.
That's possible because sometimes in the core, new classes fall into the category of like human beings being human and that kind of stuff. It has nothing to do with CS. It just, yeah, I mean, our required courses have not changed. As far as I know, the only class that we require is that you take stats. I think that is the only required class for computer science. I think the logic course is something we recommend. I think it ticks a box for one of the I don't remember which of the it's not the human beings being human, but it's something along those lines. Well, I think that's the human beings being human thing, but whatever. At the university level. Yeah, that's potentially possible. Yeah. That's not my purview, you know.
I did medieval philosophy.
Medieval philosophy? We should just build a guillotine. Yeah, that went dark so fast.
Yeah, medieval philosophy is like.
Oh, that was a pretty good one. First day of class. We hope your woodworking skills are up to snuff. All right, let's focus on this stuff. You guys can make your future schedules. Well, you need to suck less next time. Basically, as a rule of thumb, you cannot trust DegreeWorks for anything. Just take that to the bank. DegreeWorks is saying you're missing something and you don't think you are, you probably are not. All right. So shut up. All right. So if you remember from the end of last class, we ran into a issue, right? We are trying to create our death match, and I think it's our referee that spins that guy up, right? So here's our referee, controller, dealy flippy guy here. So we had a delay before the fight. Then we told our death match to start fighting, right? All right. So that is, what's the name of my death match? The match. This dot the match dot fight. All right. So we told that guy to start the fight after waiting a half a second. That way, when you first come into our fight scene, they don't just immediately start killing each other. There's a kind of a little pause, let the music kick on, get you in the mood for the fight. Tighten the screws on the guillotine thingy. I don't think they use screws. They probably hammered in the planks or whatever those are called. All right, so that then brought us in here to fight, and where we ran into issues at the end of class last time was our nice little while loop here, where we said, hey, we're going to do this forever. Effectively, we want to do this until one of our guys dies, right? Okay, well, the issue with this is last class we introduced the concept of threads inside of Unity. So we did this with this thing called a coroutine. Okay, which is effectively like threads were in Java. Okay, and what we would do is inside this while loop, we would decide, this is the flip-flop stuff right here, where we decide whose turn is it currently, right? And just kept going back and forth on who gets to hit who next. And then we would start the coroutine to do this. And that's this guy up here, the move object routine, right? All right, that makes him look like he's getting ready to fight. Right. The issue is that if you remember back from Java, this is a non-blocking line of code. That means we hit that, spin off the thread, zip right back up to the top of the while loop, and change who's attacking next, launch the next thread. Okay, so these guys are going to go, if it didn't crash, right? They're basically going to just be constantly having overlapping threads since our coroutine waits for some amount of time, right? So we come into our coroutine, we decide where's his original position, and the original position is relative to whoever is currently attacking, right? And the whoever is currently attacking gets figured out right here. That's where we set up those variables and then set it up for the next time around. All right. So back up here, we get our couple of positions based on who is currently attacking so that we can make that guy move and then go back. So we have him move to that position, which is a ninja move of the rigid body. He has a move to position thing where we give him a target. Then we kind of have this coroutine, this thread go to sleep for half a second. Then we move him back and then go to sleep for half a second again. So with a little bit of overlap, since all these things do take some amount of time, we basically are spending at least 1 second in this coroutine. Call it 1.1 seconds, close enough. More than a second we're spending inside this coroutine. Well, we've already decided, and we saw last time, that while loops, this guy's going to loop through many times in 1.1 seconds, right? That means you're spinning off thread after thread after thread after thread, and Unity croaks. All right. So we don't want our next guy to move until after the first guy has finished moving, right? So even though this logic here governs the fight, right? The logic here says, oh, well, when a fight starts, we want the players to go back and forth, back and forth, back and forth. Now we are managing the visual side of our game, in MVC, the view, because we want to just see our guys ping back and forth. We're not doing any damage yet, right? But we just want to see them ping back and forth. So where do we put the code to make sure that the next guy moves after the current guy has finished moving? Who knows when the current guy has finished moving? This coroutine, right? So the current guy has finished moving as soon as he's finished waiting for a second, half second, right? And now this coroutine, even though it's in its own thread, he lives inside of our deathmatch class. Therefore, he has access to this instance of the deathmatch. So he can go ahead and say this dot fight, which we'll put a little comment here. Call the fight method again after this guy is done moving. All right. So he'll go ahead and call that guy again, which sets up the things for the movement of the next dude, stages it for the next time, so on and so forth. All right, that makes some sense. Now, I would somewhat call this kind of halvesy recursion. Remember what recursion is? I think we talked about it at some point. What's recursion? Go ahead.
Where function calls the function.
Yeah, when a function calls itself from within itself. And kind of the easiest example of recursion is like factorial. 5 factorial is 5 times 4 times 3 times 2. But what is 5 factorial actually? It's 5 times 4 factorial. What's 4 factorial? It's 4 times 3 factorial. 3 factorial is 3 times 2 factorial. 2 factorial is 2 times 1 factorial. 1 factorial is 1. That's where you finish, and then all the other ones unroll. Recursion is memory inefficient, since every single time you put a function on hold, it has to kind of pause this and say, well, 5 factorial can't finish until it gets its answer about 4 factorial. Who can't finish until he gets his answer about 3 factorial, so on and so forth. And then it all unwinds. So this is sort of kind of a recursive little ninja move here, where the fight function spins up a coroutine, which ultimately calls the fight function. Make sense? It's not truly a recursive model since things aren't being put on hold. It just happens at the right time. We are using the coroutine timing to make this happen visually. All right, so if we run this now, we should get this back and forth ping-ponging with our guys, and it should not crash Unity because we have commented out our while loop. So we're not doing that forever. Oh, of course it's going to work, right? Of course it's going to work. Look at that. What we have to have there at the end of the death match, once they actually knock we have to bring in a guillotine. It's like finish him and just incorporate Mortal Kombat into our Zelda Final Fantasy mashup. All right. See, now you don't have to take like history of yeah, well, or that. I was thinking the history of video games or something. When we were covering, we got the 80s in there. Mortal Kombat was 90s, right? The original. Yeah. Can you? You'd probably do it with an animation. You'd probably have the different parts of your. I think we're talking about a beheading at this point. You have the different components of your beheading, and you build an animation around that, and probably go super slow-mo on the separation, and then maybe some tumbling. Put just a random flight of stairs just in the scene for no good reason. This class has become very dark today, so it's only Wednesday. It's like, all right. Hey. All right, so now we have our guys doing their back and forth dance. Now we want to actually have them do some fighting, right? Let's have them physically be doing some damage to each other. I need to remind myself here, do we already have our stuff up there for our, oh, I don't want that one, I want that one. We have our 2 different player stuff thingies. This will give me an error in a second, but let me just see. All right, so I have, oh, that's the monster, that's the player. All right, so let's go ahead and get those things filled in. All right, so we want, I thought we had our player showing up, didn't we? Oh, he's just not showing up there because the player isn't set to, we'll get specs for stats for both of them now, right? Yeah, there we go. All right, so now what we want to do is we want to start having that logic of try to hit the other guy, right? If you clear his armor class, then do some damage. Otherwise, do nothing. All right, so go back to our code here. Where are we going to accomplish that? All right, so this coroutine here, all this guy does is he starts up the movement code here. Now we can go ahead and we could figure out damage and stuff inside the fight here if we want, right? And then update that inside of well, we can update it outside of there, or we can update it inside of the routine, because we know the next swing isn't going to happen until this guy's already moved. I would be inclined to go ahead and put my logic to potentially take damage. Try to hit target here after our guy's moved. So he's moved in to take a cut, right? Then he figures out if he hits or not. We do damage if damage should be done. Well, move to do his hit and then move back. And he either hits and maybe we do something, or he misses and then we do nothing. But you know, that's, I think that's maybe where it should be. Unless you wanted to play the game of don't have him move at all if he misses. Because I kind of imagine if this was a real fight going on, your guy would step in and try to hit, but if he didn't clear the armor class, he just wouldn't do damage. There's still an attempt at hitting. So you can decide what makes the most sense for your game, but let's go ahead and try to do it here. So right now, we know who the, let's see, do we know the current attacker and things like that? So we are currently inside of our death match. And inside of our death match, we have our dude 1, dude 2, we have our current attacker. We probably also then want to have our current target, private inhabitant, current target, and then flip-flop those two guys. All right, so initially, here's my constructor. We have our current attacker is dude 1. We'll go ahead and set our current target is equal to this dot dude 2. All right, that way we know the people that are trying to hit each other, right? And then we want to flip-flop those guys. So down here in fight, we're flip-flopping game objects here. So inside of here, if the current attacker used to be dude 1, now we need to go ahead and make this dot current attacker is equal to this dot dude 2. This dot dude 1. And then we also need to update the target. This dot current target is equal to this dot dude 1. This dot current target is equal to this dot dude 2. Right, so these are updating our models, right? We're keeping track of who's trying to hit who here. We're already making the visuals alternate. Now we're making the behind the scenes inhabitants go back and forth, so that inside of our coroutine, we can say, does the current attacker hurt? Does he hit the current defender, the current target? Yes or no? All right, so we could write that generic logic in there. All right, so inside here, this is where we'll actually write our, do I have I had this up with our stuff, right? All right. So we're going to try to attack. So a successful attack means that a D20 is at least as high as the target's armor class. Okay, well, so we can decide if we want to create some dice. We can create a dice class here that we can use, right? Or we can just roll random numbers if we want to do that. I don't know. We're going to do both. All right, so I'm going to go ahead and I need to go here. But why? It's not popping up my Unity. The project's already open. Yes, I'm aware. Okay, but that was a different project. Still a different project. Just for no good reason, I couldn't pop up the screen. All right. Oh, it's because it is angry. What happened? That probably was all the back and forth stuff I was doing. Things just junk. Okay. All right, so we're gonna go ahead and I'm gonna give myself a class here. We're gonna create a class C# script. We're gonna call this guy Dice. We'll go ahead and open this dude. He is not going to be a mono behavior. And we're going to go ahead and have a public static int roll method. So we can say dice.roll 20, dice.roll 6, whatever, that kind of stuff. All right. So I don't need any of these things actually. And what is it? What class is random in? Oh. Which one did we use? We used Unity one. What was the Unity one for random numbers? Okay, and there's a couple of versions of this. So we're going to do range 1 to, okay, 1 to sides +1. Return that guy. And it's side. Well, probably should be sides. All right, so we'll just create a quick little dice class that has a static method called roll that I pass the number of sides into, and it'll give me a number between 1 and the number of sides. Okay, and since it's static, how do we call? It's a class method. How do we call class methods? Using the name of the class in which the method was defined. So that means inside of deathmatch. Okay, we can go ahead and say if dice.roll 20 is, it's at least as high as the target's armor class, so it needs to be greater than or equal to this dot current target dot, we need to give ourselves the ability to give our armor class. So we're going to go into inhabitant here. Inhabitant already has a hit points, an armor class, a damage. These guys are all protected. I have a thing right now just to get the full data string. We're going to go ahead and give ourselves a public int get AC. This guy will return this dot AC. Then we want to also have the damage, public int get damage. This will return this dot damage. And damage is a int. Okay. Why is this? Why is he? Oh, thank you. All right. Now we're going to have them take some damage. We'll come back and write that here in a second. So we're going to go back to our, where's this in referee? No, it's in deathmatch. Good match here. All right. So if our D20 roll is greater than or equal to our current target's armor class, if that's a true statement, then we want our current target to take some damage. How much damage he's going to take? The amount of damage that our attacker does, right? Okay, so we'll go ahead and inside of inhabitant, we're going to say public void take damage. And we'll say this dot damage minus equals damage. If you don't like the minus equals thing, you could say this dot damage is equal to this dot damage minus the damage that was just passed in. So that will make his hit points go down. But only if he got hit. Make sense? Oh, thank you. Thank you. Take damage is reduce this guy's hit points by the amount of damage that's done. So we're right back to the what is the medieval philosophy. You know, instead of hurting their hit points, we just make them hit less hard next time until he's just this empty husk standing there, unable to hurt you. In fact, future swings actually heal you. Oh, actually, no, it'd be future swings actually make you hit harder. This guy's just sitting there swinging for the fences. Okay, so we'll reduce his hit points by the amount of damage that's done. So back in deathmatch, if we hit, then we'll say this current target dot take damage. How much damage? This dot current. Why isn't it finishing? Here, I can get damage. All right, so we'll tell our current target to take some damage. How much damage? Our current attacker's damage. All right. Now, we might want to ask the question, did the dude just die? Okay. For right now, though, let's just see that it's going down. So we're going to update our sign. Where am I doing that? That in referee controller. Okay, yeah. So the referee guy, he passed himself in. So we do have access to our referee inside here. And we're going to go ahead and inside referee controller. Right now, we're updating our sign right there. What I'm going to do is I'm going to put those two lines inside a void update, called it update score. And then we'll just call this dot update score inside of here. So now our referee controller has a function called update score that changes the current data on the scoreboard. Okay, we'll call it once when we first start this script to get the initial settings. And then inside of deathmatch, we have access to our referee instance. Remember, we gave it to ourselves last time. So we'll go ahead and say this dot referee instance dot update score. Isn't that what I called it? Oh, yeah. Update score. What are you mad about? Oh, I bet you I didn't save this one. Referee instance does have one of those though.
Wait, did we only not say the mono behavior as the referee? And the holder?
I passed in this whole controller. This is the instance of this controller. I wonder if this needs to be public to be able to see it. I'm just going to try to run it. I'm interested. Maybe Visual Studio is just upset. Nope. Yeah, I did. I thought, well, I'm pretty sure I did. Save there. Save there. Yeah, I made it public here. So referee controller is not a I just don't know. I mean, we have an easy fix. We'll just pass our text mesh pros in there too. But why can I not call an instance method of referee controller when I have this instance of referee controller? Feels like it's a Unity thingy.
You just type in.
Well, you wouldn't that wouldn't make sense in here because then it would be equivalent to me saying this dot update controller, which is deathmatch, and deathmatch does not have that guy. Update score is our referee instance. We are setting him, right? Oh, hold on. Do we not have it set yet? Oh, yeah, we do. Let's see. Yeah, this dot referee instance is equal to referee instance. So this guy is set. What all does he think he has? Oh, I can do this. This is actually an interesting thing. It might allow us to accomplish what we're trying to accomplish here. It still doesn't tell us why we can't accomplish it. We do have, there's something called message passing. So we could have a mono behavior broadcast a message. And what it does is it sends that message to all other running mono behaviors in the scene. So if you want everybody to like call their, recent, thank you. If you want everybody to call like their respawn function or something like that, you can have one of your mono behaviors tell everybody else to do that. Well, you wouldn't want to do it here, but technically you could. What do we call it? We called it update score. This is frankly just not a great idea. but But let's just see academically if it lets us accomplish. So really what we're asking us to do is we're asking our referee instance to broadcast a message, update score, which I think will also broadcast it to itself. So all of our mono behaviors on the screen that have update score will receive that message and say, oh, we should call our update score method. We only have one guy who has an update score method, which is our referee. This is could be fun. It is updating. Mike died a while ago. But actually, oh, hold on, is this?
Yeah.
Oh, that fixed that. Did I undo what I was doing? Take damage is our current target. Here's inhabitant. Did I not save this one? That guy wasn't saved. Now we see how bad it is when that the dude was just. All right. Are they not hitting each other? All right, so we made it work, but I actually kind of hate this.
They like attack.
Well, I mean, this was not on purpose, obviously, but this is kind of an important thing, and it goes back to something I talked about before. When I've talked about really for the last 2 semesters. When you make a change to code, you want to make it because you think it's going to do a specific thing. You don't want to just keep randomly changing stuff till it works. This time we made an educated guess that, okay, I can broadcast the message to all mono behaviors, knowing that only one of them happens to have a function called update score, and that will get called. That still does not tell me why I can't say in here, this dot referee instance dot update score is not callable. Referee instance is an instance of mono behavior, which is fine. I mean, but before it's an instance of mono behavior, it's an instance of a class called referee controller. Well, okay. I mean, I think what you're saying is, could I just do this? Can I say, that guy? Well, he's happy with it now. Why is this not? Oh, it's because I told it was a mono behavior. Hey, where's that guillotine? So this is why types are important. In my death match, I wanted to give myself access to my referee controller. Well, I didn't take in referee controller as a parameter. I took in a mono behavior. Fine. So that means when I sent in this as my referee controller, it came in as a generic mono behavior, even though I know that it's actually referee controller. There must have been a reason we did that. Did it not allow us? Oh, this guy maybe didn't know about referee controller. That's possible. It was in a different namespace. So that's why we had to take in the generic mono behavior, which is told to us up there. So when we took in our actual instance of referee controller, it came in as a generic mono behavior. So we kind of had it in this box labeled mono behavior, yet we put a referee controller inside there. So then down here, when we tried to call our update score on our referee instance, it was checking syntactically, does mono behavior have an update score? It did not. But we happen to know that what's inside this box is actually a referee controller who does have an update score. So we typecasted it here to say, okay, I know you look like a mono behavior, but you are actually a referee controller. And now I want you to call your update score. So now we're not broadcasting the message, we're sending it to everyone. And we should get our updates here. Feels like these guys have too high of armor classes, or they don't hit hard enough. Yeah, we do have to have the audio on for that. Whenever he gets hit, just have him like scream. No! You missed me.
Yeah, I just noticed that.
What's happening? This is HP over here.
But it's going down when, so
When
like
they're just
you're-
standing there.
Yeah, no, Mike is, yeah. That's what I just saw.
Let's see when we're doing it. Oh, well, because we are updating the score in the middle of their attack when they're still forward. So we could just do it right before we call our fight. That way he's already bounced back before we update it. So that's just positioning. When did we want to update those panels? Now he'll pop out, then go back, and we'll update the panels. All right. So this is truly enthralling. All right. So now we need to have a guy die at some point, right? So when somebody finally gets their hit points down below 0, we want him to die and we want the other guy to win, whatever that means, right? Okay. So we need to be able to ask the question after a attack is done. We want to check our opponent and say, you dead? Before we just call fight again and move on. So inside of our code here, maybe inside of our coroutine, if he took damage, and actually what we can do is we can just always check. We'll update the score. We'll ask the question, if this dot current target dot, maybe we're going to write a function in there called is dead. So we're going to teach inhabitants to tell us true or false whether or not they're dead. So inside of inhabitant, we'll create a public bool is dead function, and we're going to return, we want to return true if he's dead. So return this dot HP less than or equal to 0. So it's true that he's dead if his hit points have gotten to 0 or worse. Make sense? So now an inhabitant can give us that information. So back here, we can say, if my current target is dead, which means that I kind of just hit him and he's hurt, I could put the logic up there where I only actually check if he's dead if I successfully hit him. If I wanted to, but this is a little question, not a big deal at this point. So we can just say, hey, I don't know if I hit you or not, but I've already moved in to attack. I potentially hit you. I moved back. Now I'm going to check on you before I just call fight again. All right. Where I'm asking now a corpse to try to attack, which he will happily do in our current logic, right? So if the target is dead, we're going to do one thing else. we'll call our fight again. All right. So if they're dead, we need to maybe end the scene, something like that. Maybe have some sort of, like victory dance, type thing. So, what happens when our fight is over? So what do you think? What should we do when the fight is over? Go ahead.
Probably should check, right?
We already know who died. Who died right here? Current target's dead. And we know that we also have access to his game object, whatever. But I mean, that's a good point. That's why we wrote it this way, is at all points in time, we know about the current target. We don't currently actually have the current target's game object. Right? So, because you're suggesting, I mean, realistically, do we need the current target's game object? If he's laying there dead, well, we might want to knock him over. Yeah. just rotate him. So we can give ourselves access to that game object. So if we want the current target go, I'm gonna just rearrange these variables just a little bit. So now we're gonna have a current target go, and this guy will be a game object. All right. So then initially we have our current attacker and a current attacker go. Then we'll have our current target and our current target go. And this guy will be equal to this dot dude 2 go. So we're keeping track of two different things. This is kind of that MVC idea, right? We have our game object that's on our view, and then we have our instance of inhabitant that is in our model behind the scenes. That's our current source of our data for our fight. All right, so now we have access to both of these guys. We do need to make sure that down here, whenever we update the current target, we also update this to this dot dude 1 go. This dot dude 2 go. All right. So now we have access to both of those guys. So what happens when the fight is over? Well, we can do a couple things. We can, so maybe one, make the dead guy fall over. 2, make the winner jump up and down. 3, play victory music, which I think I do already have in here. So here's my audio. That's our victory music. If you'd like to use different victory music, you can. All right. So what happens when somebody's dead? Make the guy who died fall over, probably rotate him. So figure out how to do that. There's actually some example already in my version of the code that does it. Make the winner jump up and down. That's something you have done before with maybe you just apply a force to a rigid body a little differently. than you did before. Instead of pushing it forward, you push it up. Hard. Oh, that's true. Just you could do move position, I guess. All right, and then play victory music, which you're gonna have to figure out how to do that. Okay, but all the things you need to know, you've learned. Go ahead. Oh, that's up to you. I would say when either whoever wins, play the victory music. But I get the question he's asking is really we usually only celebrate the player, right? Where right now we're generically handling this as just dude 1 versus dude 2. So typically, if you were playing the original Final Fantasy, if your guy won, you would play the victory music. If your guy lost and keeled over, you would have other music playing that leads you to a game over screen. Right? Is it sad music? Oh, I kind of do remember that from Final Fantasy. Yeah. If you want to get creative with it, please do. But for right now, I've given you the music that I want you to play. Have the loser keel over, have the other guy jump and play the music. All right. Questions, comments, concerns. That's for Friday. And all that goes right in here. Well, all that should start right in here. So I'll push the current version of the code so you have it.
Are you having the common figure into CD?
Just make sure everything.
It's going to be a problem. Have to take your science.
Okay, I will show you how I did it.
By the way, if I do everything that's on here, then I did everything that I needed to.